Hello friends, this video on probability part 30 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 29. Topic altogether called Bernoulli's trial. So what is Bernoulli's trial? A trial of a random experiment is called Bernoulli's trial if it satisfies the following condition. The first is the number of trials has to be finite. The trial should be independent. Each trial should have only two outcomes. Please know this is critical. Only two outcomes is possible, success or failure. Only two outcomes has to be there in the Bernoulli's trial. And the probability of success should remain same. The probability of success should be some constant for each trial. So if random experiment satisfies all these conditions, that is just finite number of trials, independent, two outcomes, and the probability of success is constant, then only that trial is called. Before we now start solving questions of Bernoulli's trial, let's understand why do we need Bernoulli's trial. So let's suppose you throw a coin head, then you get head or tail. And let's suppose my head is success and tail is failure, right? And then you keep doing for 100 times. And you want to know, let's suppose in how many times you got 10 heads or 10 tails, 10 failures or 50 failures. Those kind of stuffs you want to know, you can use Bernoulli's trial. You throw a coin, throw a die, then you say if you get even number of output, even number, that is called a success for you, and odd is a fail for you, let's suppose. And you're doing it multiple number of times, and you want to say how many times you got success and all. You can use Bernoulli trial. You have this dart, right? You know that you hit with, let's suppose, a probability of 2 by 3, you are success always, right? And your failure rate is 1 by 3. And you are hitting it, let's suppose, 100 times, and you want to know in that 100 times how many times you hit it, right? Or any kind of things you want to know. In that case, Bernoulli's trial is helpful for you if this has only success and failure, and if all are independent. If you see, when you throw a dart, you throw first dart, you throw second dart, your second dart probability is independent of first dart, right? You throw first coin, you throw second coin. Whatever you get in second coin is independent of what you get in first coin. You throw a die also, whatever you get in first die throw is independent of whatever you get in second die throw. So everything is independent. So in this case also we can use Bernoulli's trial. So let's take one example where we have to tell whether the trial is Bernoulli's trial or not first. So here 6 balls are drawn successively from this urn containing 5 red and 2 balls. Tell whether the trial is Bernoulli trial or not. In first case, the balls are replaced. Say the balls are replaced. If you see, first thing, there are 6 balls, right? So trial is finite. Trial is finite. Correct. And let's assume you get red, that means success, green is failure. So you see that you have success and failure. Correct. And if you see that probability of success, in first case I am talking about, if it is replaced, probability of success is always 5 by 7, because you take out one ball, you replace it back. So the count is always same. It is always, before the experiment is always 5 red and 2 green. So probability of success is constant and they are all independent. Thus it is a Bernoulli trial. Let's take the part 2. The ball is not replaced. In this case, trial is finite. Yes. It has success and failure. Yes. But if you see, the probability of success is not constant. If in the first case you got red, then in second case the probability of success will come out to be 1, 2, 3, 4 plus 5, 6, total 6, out of which red is 4. So it will come out to be 4 by 6 if first was red. Probability of success if first is green will be how many red? 5. Total balls will be 1 green, 5 red, 6. So if you see, the probability of success is changing. It was 5 by 7 earlier, then it become this values depending on which ball was taken. So the probability of success is not same. Also, they are not independent, right? Because the second trial is dependent on the first trial. So it is not a Bernoulli's trial. So the same jar, same ball, but if you are replacing it, it becomes a Bernoulli's trial, and if you don't replace it, it becomes non-Bernoulli's trial. So Bernoulli's trial is tightly linked with the binomial distributions. As I told that if you have the experiment of tossing a coin in which, let's suppose your success is head, right, and failure is tail, then if you have to find one success combination, you can do it, you can just toss it. Two success combination, you can do it. But let's suppose you have 1000 success combinations, right? You toss it 100 times, 1000 times. In that case, it's very difficult to do it mathematically without using Bernoulli's trial or binomial distribution. Suppose that you threw it 1000 times, right? And you want to find the number of ways when you get, let's suppose 50 or let's suppose 50 success and 950 failure. You want to find that number of ways where I get 50 success and 950 failures. How will you do that? It is very difficult, right? It is very difficult to write this combination 1000 times and check those things. There we'll use binomial distribution. Let's derive the binomial distribution first, and then we'll use the formula for other questions. Let's take an example of experiment where we have 3 binomial trials probability P and Q for success and failure. So if you see, there is an experiment which consists of 3 Bernoulli trials. So we can have this kind of scenarios: 3 success, 0 success, right? 2 success in this fashion. I mean, like this you can have, like I'll show you. You can have success or failure in first try. You can again have success failure, again success failure, again you can have success failure, here also success failure, and here also success failure. So if you see, you can have success failure, SFS, SFF, FSS, FSF, FFS, FFF. This is what I've written, right? So probability of getting 0 success is nothing but this guy, because probability of success is P and probability of failure is Q, right, given. So this will be only one possible scenario is Q into Q into Q, that is QQ, this guy. Probability of getting 1 success, if you see, there is one guy, this guy, and this guy, 3 possible scenarios, right? So if you take this guy, that means you get SFF, that is you get success, failure, failure. This guy, failure, Q, success, P, failure. This guy, failure, failure, and success. This is nothing but 3PQ square. So probability of getting 2 success, if you see, 2 success, I'll draw here, I'll put a star here. This guy is 2 success, this guy is 2 success. Right, this guy is 2 success. This guy is nothing but 2 success, that is PP, 1 failure, Q. This guy, 1 success, 1 failure, 1 success. This guy is 1 failure, Q, 2 success, right? So this becomes, if you see, 3P square Q, right? Probability of getting all 3 success, if you see, is only 1, this guy. So this is nothing but PPP, that is PQ. Correct. So if you see the probability distribution, what I got is 0, 1, 2, 3 options, and probability of this will be, for 0 it came out to be QQ, for 1 it is 3Q square P, there is 3QP square, and is here PQ. This is what you get. So if you notice this, in this case it was 3 trial, and P and Q are probabilities of success and failure. If you expand P plus Q, where P is success and Q is failure probability, and make it to the power number of trials, right? This is nothing but, if you see, QQ plus 3Q square P plus 3QP square plus PQ. You see, exactly the numbers are matching. This number matches with this guy matches with this guy matches with this, and this lady matches with this. So everything is matching actually, right? So if we assume that there are n trials, right? If there are n trials, so let's assume that there are n trials, and out of this n trials you have get, let's suppose, x success, so you'll get n minus x failure, right? If you get n success, you'll get n minus x failure because total is n trials, right? So it can be obtained, this guy can be obtained, if you see, is n permutation by x permutation, n minus x permutations. So you can solve this also if you want. So if in this case n was 3, right? So 3 permutation by you get 1 success, so 1 by 1, so that's what you get, 3 peak square. So if you see, this was for n trial. For one trial, if you see, if you want x success and n minus x failure, for one trial this comes out to be, if you see, p to the power n q to the power n minus x, correct? Success, x success, p to the power x actually, and q to the power n minus x. So if you multiply these two, this is for one trial, is for n trial, you multiply these two, what you get, that is probability for x trials comes out to be, this guy is ncx, p to the power x, q to the power n minus x. This is the formula we have for Bernoulli's trial binomial distribution, right? So if you have n trial and you want to find x success, so that comes out to be ncx, and the probability of success p and probability of failure is q, then p to the power x, q to the power n minus x. So this is very similar to the expansion of the binomial thing, p plus q to the power n, right? That is the expansion of p plus q to the power n, actually, n permutation by x factorial, n minus x factorial. So the same thing I wrote here, x success and n minus x failure can be obtained in this ways. This I found using the binomial expansion, and the probability of x success and n minus x failure is this guy, right? This also we have seen by observation, right? And if you combine these two, the probability of x success in n Bernoulli's trial now will be this guy into this guy, that is this guy. The final formula is the probability of x success in n Bernoulli's trial will be ncx px q to the power n minus x, where p is the probability of success, q is the probability of failure, right? And n is the number of trials, Bernoulli's trial, and x is the count we are looking for. You're looking for 1 success or 2 success. This is the formula we have, and we have observed that the px, the probability of success, is nothing but x plus 1th term of this expansion. This is to the power n, right? So if you see, x plus 1th term, so probability of 0 is nothing but 0 plus 1, 1th term. This is the first term, this is the first term, this is the second term, and this is the n plus 1 term, because the expansion of p plus q, this is p plus q plus p to the power n, will have n plus 1 term. So first term will be this, second term will be this, and n plus 1 term will be the probability of n success, correct? So it is q plus p to the power n. Please note, it's always q plus p to the power n by convention. It is not p plus q. So generally we do this way, q plus p to the power n. So for 0 success, it's all failure, right? So we get n failure. For 1 success, you have 1 success, 2 success, 3. P to the power is always success, right? Because p stands for success and q stands for failure. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.